Solar panels are becoming a popular choice to generate electrical power for both homeowners and electrical utilities. But how exactly are solar panels made, and how does turning sunlight into electricity without any moving parts work? Solar panels, also called photovoltaics, are made up of layers of different semiconductor materials based on crystalline silicon, layered on top of each other, in between a top layer of protective glass and bottom layer of conductive material. The layers of semiconductor material are divided up into sections called cells by conductive strips called fingers, leading to bus bars that run across the whole panel, making the familiar grid pattern you may recognize. An easy way to visualize how solar panels work is like an LED operating in reverse. Instead of light being emitted when voltage is applied to the LED terminals, solar panels generate a voltage when light shines on the area where the two different semiconductor materials meet. When sunlight shines on the semiconductor junction area, electrons, the negatively charged particle of the atom, absorb the energy and are released from orbits around the atoms. The flow of electrons creates the voltage difference and electrical current that we understand as electrical power. Typically, individual solar cells only produce a few watts of electrical power when exposed to full sunlight, like a small battery. However, when joined together in large panels, they produce enough electricity to power a house, and in larger installations, they can produce enough to power a town. Solar panels do not connect directly to the power grid or run household appliances. The electricity solar panels produce needs to pass through a system called an inverter, which changes the direct current, DC, produced by the panels into the alternating current, AC, that the electrical transmission system and most appliances use. There are few different types of solar panels, each with their own benefits and drawbacks. The monocrystal cells are a solar cell made from one large silicon crystal. During the manufacturing process, pure molten silicon is slowly cooled and shaped until one large crystal is formed called an ingot. The silicon ingot is then cut to size and chemically treated to form individual solar cells. Due to using a single silicon crystal for each cell, the overall efficiency for the panel is quite high, up to 26%, but the manufacturing costs are also higher due to the more involved process. Opposite to monocrystal cells, polycrystal cells are made up of many different silicon crystals that have been melted together and allowed to cool, forming random crystal arrangements. This less expensive and simplified construction method allows for a lower price for the finished panel, but the many different crystal boundaries create imperfections in the cell, resulting in lower overall efficiency compared to monocrystal cells, typically in the range of 15 to 20%. Efficiency aside, polycrystal silicon-based solar panels are the most popular type of solar panels on the market. Thin-film solar panels, also called amorphous solar panels, are made by layering thin layers of photovoltaic materials such as amorphous silicon, cadmium telluride, or gallium arsenide. Without the need for solid silicon crystals in their construction, thin-film solar panels are much thinner and can even be placed on flexible plastic backing. The simple construction and low cost of thin-film solar cells have allowed them to spread far into the market from consumer devices and rooftop installations, and they can even be found in electrical grid utility projects. Depending on the exact materials used, thin-film cell efficiency can range from 6 to 15%, but as an area of active research, this continues to increase. For more information about energy harvesting and sustainability, be sure to check out DigiKey's application and technology page.